Hello students, in this video we'll do the short answer type questions of exercise 8.5. okay, if you find this video helpful, then please don't hesitate to subscribe the channel and hit the like button. It's absolutely free of cost for you, but it motivates me a lot. Okay, so let's start exercise 8.5 short answer type questions. Question number 3. Question number 1 is question number 1 of 3. Let us write the simplest value of b square minus c square whole cube plus c square minus a square whole cube plus a square minus b square whole cube, okay, whole upon b minus c whole cube plus c minus a whole cube plus a minus b whole cube. So we are asked to find the simplest value of this expression, isn't it? Before we solve this question, let's see the formula first. Since we know that a cube plus b cube plus c cube minus 3abc equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, isn't it? Now if a plus b plus c equal to 0, if a plus b plus c equal to 0, then we can write a cube plus b cube plus c cube, okay, equal to, so this is 0, isn't it? 0 into this is 0. A plus b plus c is 0, so 0 into this is 0. So we have 0 in the right hand side. Now we take this minus 3abc to the right hand side. Okay, a plus b plus c is 0, 0 into this means 0, so we have 0 in the right hand side. So we take minus 3abc to the right hand side, becomes plus 3abc. So we remember this, if a plus b plus c is 0, then a cube plus b cube plus c cube equal to 3abc. Now we will find the value of this expression. Okay, first let's understand this b square minus c square is a. Let's suppose this as a, this as b, and this as c. A cube plus b cube plus c cube. Okay, we suppose b square minus c square as a, c square minus a square as b, and a square minus b square as c. Okay, now let's find the value of a plus b plus c in this case. Okay, so b square minus c square, this is a plus b, isn't it? B is c square minus a square, c square minus a square, this is b, plus c is a square minus b square, a square minus b square. So we have minus b square and plus b square, 0, plus a square minus a square cancels out and becomes 0, plus c square minus c square is 0. So we got a plus b plus c equal to 0, isn't it? This is a plus b plus c equal to 0. We got a plus b plus c equal to 0, which means this whole thing is 3abc. If a plus b plus c is 0, then we can write, let me continue here. Okay, so I'm writing the numerator part. So we have a cube plus b cube plus c cube. We got a plus b plus c as 0, which means if a plus b plus c is 0, then a cube plus b cube plus c cube must be equal to 3abc, which means 3, a is b square minus c square. This is a. B is c square minus c square, c square minus a square. C is a square minus b square. 3abc, because we got a plus b plus c 0. If a plus b plus c is 0, then a cube plus b cube plus c cube must be equal to 3abc. If a plus b plus c equal to 0, then a cube plus b cube plus c cube must be equal to 3abc. So we got a plus b plus c 0, then a cube plus b cube plus c cube must be equal to 3 into a into b into c. Now let's see the denominator part. We have b minus c whole cube plus c minus a whole cube plus a minus b whole cube, isn't it? So this we assume as a cube plus b cube plus c cube. Let's find the value of a plus b plus c. A is minus b minus c, this is a, b is c minus a plus b, plus c is a minus b, isn't it? Now this is a plus b plus c. So plus b and minus b cancels out, becomes 0, plus a minus a cancels out and becomes 0, plus c and minus c also cancels out and becomes 0. So we got a plus b plus c as 0. When we have a plus b plus c as 0, then we can write a cube plus b cube plus c cube as 3abc, isn't it? 3 What is A here? A is B minus C. And what is B? B is C minus A. And what is C? C is A minus B. Okay, this 3 and this 3 cancels out. Now we have B square minus C square in the numerator. Let's apply the formula A square minus B square. B square minus C square is B plus C into B minus C. So C square minus A square is C plus A into C minus A. And A square minus B square, A plus B into A minus B, isn't it? In the denominator we have B minus C into C minus A into A minus B. So we have B minus C in the denominator and B minus C in the numerator. We cancel this. C minus A in the denominator, C minus A in the numerator. We cancel this also. A minus B in the denominator, A minus B in the numerator. We cancel this also. So we have B plus C into C plus A into A plus B, isn't it? So we write this first, A plus B, okay, and then B plus C, and then C plus A. So this is the answer for question number 1. Okay, now let's do the next one. Okay, now let's do question number 2. Let us write the relation of A, B and C if A cube plus B cube plus C cube minus 3AB is equal to 0 and A plus B plus C not equal to 0. Okay, so these two are the given conditions and we are asked to write the relations among A, B and C, isn't it? So let's use the first condition, A cube plus B cube plus C cube minus 3AB is equal to 0. Okay, the first condition is A cube plus B cube plus C cube minus 3ABC equal to 0. This is the first condition. So you know this, since A cube plus B cube plus C cube minus 3ABC means A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Okay, so A cube plus B cube plus C cube minus 3ABC means A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. So this equal to 0 means this must be equal to 0. These two are same, isn't it? Because the formula for this is this. We know this, isn't it? So according to this relation, product of these two expressions A plus B plus C into this equal to 0, which means either this must be equal to 0 or this must be equal to 0. This into 0 equal to this, or this into 0 equal to this. This into 0, A plus B plus C into 0 equal to this, or this into 0 equal to this. Among these two expressions, one of these two expressions must be equal to 0. But the second condition is A plus B plus C is not equal to 0. A plus B plus C is not equal to 0. This is given to us. This is not 0. Means this must be 0. Because this number into 0 will give us 0. So this expression must be equal to 0. Or therefore we can write, since A plus B plus C not equal to 0. Therefore we must write A square plus B square plus C square minus AB minus BC minus CA must be equal to 0. Among the product of these two numbers, this and this equal to 0, isn't it? If this is not equal to 0, then this must be equal to 0. So this into 0 will give us 0. This means this equal to 0, isn't it? Okay, now if we multiply both sides of this equation with 2, okay, 2 in the left hand side and in the right hand side also we multiply with 2. 2 into this, 2 into 0. Okay, multiplying both sides of this equation with 2. Now we get 2 into A square, 2A square plus 2 into B square is 2B square plus 2 into C square is 2C square minus 2 into AB is 2AB, 2 into minus BC is 2BC, 2 into minus C is minus 2CA equal to 0 into 2 is 0. Okay, now we have here 2A square. Okay, so I write A square. So a square is still remaining, because a square plus a square plus a square will give us 2a square, isn't it? So I'm using one a square, so another a square is still in my hand. Okay, a square minus this 2ab, I write here minus 2ab, and then we have 2b square here, so I'm using 1b square here, so still 1b square is in my hand. Okay, so a square minus 2ab plus b square. Now I wrote b square here, we had 2b square here, so another b square I write here, b square plus b square is 2b square, minus I'm using this 2bc, and b square minus 2bc plus c square. Okay, here we have 2c square, I am writing c square here, another c square is still remaining, so I am writing that c square here again. C square plus c square is 2c square, minus this 2ca, and then we have a square here, isn't it? 2a square, I wrote a square, another a square I write here, that a square equal to 0. Let me check this. This a square plus this a square will give us 2a square. Okay, this c square plus c square is 2c square, b square plus b square is 2b square. This minus 2ab is this minus 2ab, minus 2b is this minus 2bc, minus 2ca is this minus 2ca. Okay, so this is, or a square minus 2ab plus b square is a minus b whole square. So this one, b square minus 2bc plus c square is plus b minus c whole square, plus c square minus 2ca plus a square is c minus a whole square, isn't it? Equal to, we have 0 in the right hand side. Now if the sum of squares equal to 0, if sum of squares equal to 0, then each square must also be equal to 0. Okay, this means a minus b whole square should be equal to 0, and b minus c whole square should also be equal to 0, and c minus a whole square should also be equal to 0. Okay, if a minus b whole square equal to 0, then a minus b equal to, we take this square to the right hand side, so root under 0 means 0, which means a equal to b, a equal to b, isn't it? We take this minus b to the right hand side, becomes plus b, so a equal to b. Now similarly, b minus c equal to, we take this square to the right hand side, becomes 0, square root of 0, which means 0, or b equal to, we take this minus c to the right hand side, b becomes, b equal to c, minus c becomes plus c in the right hand side. C minus a equal to, this square we take to the right hand side, becomes root under 0, root under 0 means 0, or c equal to, we take this minus a to the right hand side, becomes plus c. So a equal to b, b equal to c, and c equal to a, which means we can write a equal to b equal to c. Okay, relations among a, b and c are a equal to b equal to c. Okay, a equal to b equal to c. Question number 3. If a square minus b square equal to 224 and a and b are negative integers, also a is less than b, then let us write the values of a and b. So this is the given equation to us. We are asked to find the values of a and b from this equation. Conditions are a and b are negative integers, and another condition is the value of a is less than the value of b. So we are asked to find the values of a and b, isn't it? So let's see the equation. Since a square minus b square equal to 224, this is the given equation, isn't it? So from this equation we will find the values of a and b. Okay, or a square minus b square equal to, instead of 224 we write 225 minus 1. 225 minus 1 is 224, isn't it? Or a square minus b square equal to, this 2 to 5 we write as 15 square. 15 square means 15, 15 ja 2 to 5. This minus we write here 1 means 1 square. So 1 squared is 1, 15 squared is 2 to 5. Okay, or a square minus b square equal to, since a and b are negative integers, the condition is a and b must be negative, isn't it? So what do? Is we write minus 15 square. Okay, when you put a square here, this minus doesn't affect. because when the power is even number, this minus will change to plus. So minus 15 square and plus 15 square, same thing. Okay, minus 15 square means minus 15 into minus 15. So this will give us minus into minus is plus, 15 15 that 2 to 5. So this 2 to 5, isn't it? So minus 15 square or plus 15 square, both will give us plus 225. This minus we write here. So we have 1 square here. So we can write minus 1 square here. So minus 1 square means minus 1 into minus 1, that is plus 1. Okay, plus 1 square. Or okay, now we have a square is this and b square is this. Okay, a square is this minus b square is this. This minus and this minus same here. B square is this. So if a square equal to minus 15 square and b square equal to minus 1 square. So we leave square from both the sides. A equal to we leave square from both the sides. So a equal to minus 15 and b equal to, we leave squares from both the sides, b equal to minus 1. Now among this a and b, which one is greater? Obviously a is smaller than b, because when we put the negative sign, the greater the number, lesser will be its value, isn't it? So this is the number line here, 0, 1, 2, 3, and here minus 1, minus 2, minus 3 and minus 4 and so on, isn't it? Among this minus 4 and minus 1, which one is greater? Minus 1 is greater than minus 4. Minus 1 is greater than minus 4, because if we move from left to right, the value of the number increases. Minus 3 is greater than minus 4, minus 2 is greater than minus 3, minus 1 is greater than minus 2, 0 is greater than minus 1, 1 is greater than 0, 2 is greater than 1, 3 is greater than 2. If we move from left to right, the value of the number increases. So minus 15 is lesser than minus 1. So here we have a less than b. Okay, the second condition, a should be less than b. A should be less than b. So we were asked to find the values of a and b. Therefore the values of a and b are a equal to minus 15 and b equal to minus 1. So this is the solution for question number 3. Okay, question number 4. Let us write the value of x minus a whole cube plus x minus b whole cube plus x minus c whole cube minus 3 into x minus a into x minus b into x minus c if 3x equal to a plus b plus c. So we are asked to find the value of this expression if 3x equal to a plus b plus c. Condition is 3x equal to a plus b plus c. So before we proceed to find the value of this expression, let us see the formula. Since a cube plus b cube plus c cube minus 3abc equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, isn't it? This is the formula. If a plus b plus c equal to 0, if a plus b plus c equal to 0, if a plus b plus c equal to 0, if this equal to 0, then 0 into this will give us 0. 0 into any number is 0, so 0 into this will give us 0. Therefore a cube plus b cube plus c cube minus 3abc equal to 0. Okay, if a plus b plus c is 0, then a cube plus b cube plus c cube minus 3abc will become 0. 0 into this is 0. Okay, 0 into this is 0. Now let us see the given expression. X minus a whole cube plus x minus b whole cube plus x minus c whole cube. Let's assume this as a. Okay, this b and this as c. A cube plus b cube plus c cube minus 3abc, isn't it? So let's find the value of a plus b plus c from this expression. So since a plus b plus c, let us find the value of a plus b plus c. Since a, what is a? A is x minus a plus b is x minus b plus c is x minus c, isn't it? So this is a plus b plus c. Or this is x minus a plus this is x minus b plus this is x minus c, or okay, equal to x 2x, 3x. 3x minus a minus b minus c, minus a minus b minus c, isn't it? Now we have 3x equal to a plus b plus c. This is given condition. 3x equal to a plus b plus c, isn't it? Which means instead of this 3x, I write a plus b plus c. This is given to us according to question. 3x means a plus b plus c. So 3x means a plus b plus c, minus a minus b minus c. Okay, so this plus a and minus a cancels out, plus b minus b cancels out, plus c minus c cancels out, so we get 0. So a plus b plus c, a plus b plus c is 0. If a plus b plus c is 0, if a plus b plus c is 0, then a cube plus b cube plus c cube minus 3abc must be equal to 0. So if a plus b plus c equal to 0, then a cube plus b cube plus c cube minus 3abc must be equal to 0. Therefore, we can write x minus a whole cube plus x minus b whole cube plus x minus c whole cube minus 3 into x minus a into x minus b into x minus c. Okay, a cube plus b cube plus c cube minus 3abc equal to 0. So we were asked to find the value of this expression. The value of this expression is 0. Okay, now let's do question number 5. Let us write the values of a and p if 2x square plus px plus 6 equal to 2x minus a into x minus 2 is an identity. So we are asked to find the values of a and p from this equation, isn't it? So let's copy this left hand side of the equation as it is. 2x square plus px plus 6. In the right hand side we multiply these two numbers. Okay, so 2x into x is 2x square, plus into this minus is minus, 2x into 2 is 4x, now with minus a. Okay, so minus into plus is minus, a into x is ax, minus into minus is plus, a into 2 is 2a. 2x square plus px plus 6 we copy as it is in the left hand side. 2x square, now from these two numbers we take minus x common. Okay, so minus x is taken common, so here we have 4x, isn't it? So x into 4 will give us 4x. Minus into plus is minus, x into a is ax plus this is 2a. Okay, we have plus here, isn't it? Plus px, we have minus, so let's put this minus inside. Okay, 2x square plus px plus 6 equal to 2x square. We take this minus inside, so we write plus x here, plus x, we write plus x here. This plus 4 will become minus 4 and plus a will become minus a. Okay, I'm putting this minus sign inside this bracket. This minus x will become plus x, plus 4 will become minus 4, plus a will become minus a, plus 2a. Now we have same left hand side and right hand side, isn't it? So we have 2x square here, we have 2x square here, we have plus here, we have plus here, we have x here, we have x here. This p must be equal to this, isn't it? So comparing left hand side and right hand side of this equation, p equal to minus 4 minus a, and plus, we have plus this 6, we have 2a here. So comparing left hand side and right hand side of this equation, 2a must be equal to 6, 2a equal to 6. So from this equation, a equal to 6 upon this 2 will go to the denominator, 2 1s are 2, 2 3s are 6, or a equal to 3, which means p equal to, so we have minus 4 here, minus a means minus 3, a is 3, so this minus we write here, a means 3, so this a means 3, or p equal to minus 4 minus 3 is minus 7. Same sign means we must add the numbers, isn't it? Therefore, the value of a and p are p equal to minus 7 and a equal to 3. So this is the solution for question number 5. So this was the last question from this exercise. I hope you understood the concept of this exercise, isn't it? Thank you so much. Stay connected. Okay, practice well. I'll upload next chapter in the next video. Thank you.